Afternoon, mother lovers. Let's have a look at paper 2. So I couldn't find the questions. What I've done is just recreate all the facts you were given. So first fact, fact number A, is going to be the f of x was defined as this, some cubic thing. And then the second fact, fact B, is going to be that x minus 2 was a factor of f. So what do these tell us? They tell us, using the factor theorem, so fact A and fact B, they're going to tell us that when we plug in 2 to f of x, we should get 0. So let's do that. If we plug it into the top bit, we're going to have 2 cubed, which is 8. Take away, we've got 2k plus 14. And that's times by 2 squared, which is 4. Then for the next bit, again, k plus 8, but we've got times by x, so times by 2. K plus 8, and then plus the 14. And that should equal 0. So if we take that fact, what can we say? Well, let's just collect everything for k's. How many k's did we have? I've got negative 8 there. I've got 2 in that one. That's how many k's we have. Everything else then, we have that 8 from the front. We have minus 56. And we have a plus 16 and a plus 14 on the end as well. Collecting all these up then, the k's, we have minus 6, so I'll send that to the other side and say that we have 6k. And then we'll add these all up. That makes 30, that makes 38. 38 take away 56 is negative 18. So this is going to be, negative 18. And divided by 6 then, what do we get? We get that k should be minus 3. Lovely jubbly. Let's keep going. Question number 2 then, what do we get? Yeah, some trapezium rule. I wasn't sure if you were given this just like the table or you had to fill it in or something like that. But yeah, we get trapezium rule. Fill in those values if you weren't given them. We also get some integration to do for the second part. So that's going to be fact B. Trapezium rule then, when we look at it, we get the definition from that somewhere else, yeah? From like given to you in the, just in the course and it throughout the year. So what do we want to do? We're going to find the approximation. And how we're going to do that? We want h over 2, so a half of this gap. So what is that gap? 0.05 and over 2 for that bit. Inside the brackets then, what we're going to have, the first value, 11.1, plus the last value, 24.5, plus 2 times all the values in between, 13.5 plus 16.4, plus the 20.1. And then we're going to take all of those values, whack them in the calculator, see what we get, and it should have been 3.39. 3.39. Lovely jubbly. Let's actually circle our answers. What did we get on the last one? Oh, we did that. Okay, good. Part B then. We wanted to take our answer from part A and add it onto the integration we need to calculate. Why we're doing that, I'm not too sure, but that's what all the mark schemes were saying. So let's do that. Let's have a look then. Fact number B. What's that going to tell us? Well, this was fact A telling us that, wasn't it? Fact B is going to tell us when we do the integration that I is going to be. So we had 5x to the 3 on 2. Let's raise that power to 5 on 2 times by 2/5. So flipping the power and times them by it. 2/5 of 5 will be a 2. We're going to add on, well, we've got 3 there, so that becomes a 3x. And we're going to sub in the values of 0.8 and 0.6 into that. So doing that, let's 0.8 is the answer in the calculator. 2 times answer to the power of 2.5 plus 3 lots of the answer. We get a value of 3.54. And then we're going to take away, doing the same thing but 0.6. What do we get? We get 2.36. And if we do that sum before the calculations, like before we do the subtraction, the rounding, do you mean for these ones? What do we get? We get 1.1872. So therefore the answer that we're looking for is going to be that answer from part A, 3.39, plus the bit we just got, the 1. Let's give it that dot, plus the 1.1872, and that gives us then the final answer we needed of 4.58. So yeah, not sure where you're getting these numbers from, like if it was just like how you're adding it together, why you're doing that. But that's what they wanted, and I think that should be the answer that we have at the end. all looks good to me. Let's keep going. Here then, for this question number 3, we were given some arithmetic sequence, un. So fact number A is that it is an arithmetic sequence. Fact B is that when we add up the first 65 terms of that, we get 4,940. And fact C was that the 49th term was 64. So doing them, what is fact A going to tell us? Well, because it's arithmetic, we're going to get a few facts. We're going to get, firstly, that we can write the individual sequence, the nth term of it, as A plus n minus 1 lots of D. And we're also going to get that we can write the summation of it as n over 2 lots of 2a plus n minus 1 lots of D. And now then, what can we do with those? Well, let's label those. We'll label these fact 1 and fact 2. We're going to take fact number 1 then, along with fact number, double check that way around. I'm assuming so, yeah. We'll take it along, no, sorry, this one first. We're going to take fact 2 and fact B to get this one out. So, fact number 1, fact number B, what do they tell us? Well, we have this value for the sum. We have this definition for the sum. So, we can write down n over 2, with n being 65 even. So, 65 on 2, lots of 2a plus n minus 1, so 64, lots of D. That should equal the 4940. I'm going to move these all out of the way a little bit for a sec. Doing the division then. So 65 on 2, what is that? It's 65 on 2, 32.5. So if we do 4940 divided by that thing, we get 152. So the bits inside the bracket, the 2a plus 64d is equal to 152. And then divide everything there by 2. What do you get? A plus 32 lots of D is going to be 76. Lovely jubbly. Part B then, very similar idea, but we're going to take, instead of fact 1 and B, we're going to take fact, sorry, that should have been 2, shouldn't it? Fact 2 and B, we're going to take fact number 1, so the definition that it's a arithmetic sequence, so what's the nth term of it, and then a value for that nth term. So fact 1 and fact C. Together, they combine to give us that we have A plus n minus 1. N minus 1 is now 63 again, isn't it? Lots of D, and that equals to 64. And what have I done wrong there? I've used the wrong n. It should be 48, and n minus 1. N was 49. That should just be 48 straight away for 49 minus 1. And we're done. Yeah, there's not much to do in that part of it. The next part then, part C of this question, was to go through and find the actual expression for the nth term. So i.e. what are the A and the D that we've just found? Well, if we label these fact above, let's call that fact number 3 that we found. This can be fact number 4 that we found. So 3 and 4 together, if we basically do a subtraction of those. So if we think about actually doing 4 minus 3, might be a better way to write down. So equation 4, take away equation number 3. What does that give us? Well, this take away this is going to be 16 lots of D. And this take away this is negative 12. So what do we get? We end up with that D is going to be minus 3/4. That looks good. And then if we take that back in, what can we say? Move it over a little bit. We can now take this fact, let's call it fact number 5. And then with any of the ones we have above, figure it out. So let's do the simplest one, number 3. So fact number 3 and fact number 5. What are they going to tell us? Well, it's going to be A plus 32 times that D we just found of minus 3 on 4 is equal to 76. So A, therefore, is going to be 76 plus 24, which should be 100. Doesn't ring a bell in my head for the actual answer we had. Yep, A is 100. Yeah, lovely. So that's good. And therefore, then, we can call this fact number 6. We can use those two facts we've found. So 5 and 6. And the definition that we had above, fact number 1. What are they going to tell us? That the nth term of our sequence is 100 plus n minus 1 lots of D. So that's going to be a takeaway 3/4 of n minus 1. That looks good to me. We want to find now, for part D, the max value. I did a silly mistake on that one, so let's start again. We want to find the max value of the sum of our sequence. So we need to take the definition of the sum we have above. What fact number was that? That's going to be fact number 2. We're also going to take the fact that we just found, the last one, the actual definition of the individual sequence. So fact number 7. Made a silly mistake on that one. So let's start again quickly. Yeah, 2 ways to find the maximum value of the sum. First way we can do it is to take the definition we have for our actual sequence, so the nth term of the sequence, number 7, and then think about, like, when does the max value occur of the sum? Well, we're adding on values, and then we start taking away values. So if we can find the first value when we're taking away, we know that the one just before that, the one around there, is going to be the sum. So thinking about 7, we want to find not only just 7, but also when is our sequence negative. Doing that then, what we're going to see, we have 100 minus the 3/4, lots of n minus 1, and that needs to be less than 0. Let's add this bit over them. We're going to end up that the thing we have, the 3/4, lots of n minus 1, is less than 100. Times by 4, divide by 3, we'll have n minus 1 is going to be less than 400 on 3. And then adding 1 to that, we have that n needs to be less than. So, should have been greater than all the way through. We added that over, didn't we? Should have been greater than. Because just to double check that, we added that bit to that side, so it will be on the greater than side of this. So should have flipped the sign over. Adding 1 then, we get 403 on 3. So what number is that if we get like just the decimal? So 403 divided by 3, it is going to be 134 and 1/3. So if we think about the sequence itself then, it is going up and coming down. We have some value here, which is going to be like when n is, so this is going to be n. If n is 134, we're still positive. 134, we're still going up. But we know when we get to 135, we are going down. So in between those two is the peak. Where the peak's going to be should probably therefore be this one, because here we are going to take away something. Do you know what I mean? We've definitely gone down from this value. This is plotting n as if it was continuous. Actually, it's going to be discrete, so you will just have this actual value. This one we've definitely stepped down. We get bigger than 134 and 1/3. So this term, the 135th term of our sequence, is negative. So it is definitely a step down from this one. So therefore, the maximum value is going to be when we plug in 134. So good, we can call this fact number 8 over here. And fact 8 then, what does that tell us? Is that the maximum value of the sum is equal to the sum of 134. Plugging in them, what do we get? 134 on 2. 2 lots of A, so 200, plus n minus 1, so 133, times by that d of minus 3 on 4. Let's sub that all in the calculator, see what we get. 134 on 2, open brackets, 200 plus 133 times by negative 3/4. Close all those brackets, and we get a value of 26867 on 4, which if we get it in terms of decimals, in case you've got that, 6716.75. So that looks good to me. One of those will be what you put down, probably, hopefully, if you're correct, and that should be the answer to that one. So that was one way of doing it. Let's look at a different way of doing it. So the second way we can do this then is we're going to take the expression for the summation we have that we got above, so the actual definition of it, fact number 2, and we're going to combine that with the values of A and D that we found, so fact 5 and fact 6 at the top there. So 5 and 6. What are they going to tell us? Well, if we write down that expression, Sn now, still n over 2. 2 times A was 100, so that's 200. And then we have n minus 1, still n minus 1. The D was minus 3/4. So you have that many n minus 1s. And we're going to take this, we're going to expand the brackets. We'll leave that one at the front for a second. This is 200. We're going to add on 3/4. So that's going to be 200.75. Let's write it over 4. So 803 over 4. And we'll take away the 3/4 of n as well. So we can take that 8 out the front. And we'll expand the n everywhere. So we get 803 lots of n. Take away 3n squared. So what we're going to do now, we want the max value of this. So we want to take this thing and set it, like differentiate it, set it equal to 0. So that's good. And therefore then, we have, well, not therefore, but that's going to imply, let's give this a number. What number is that? That could be number 9. So number 9, that's going to tell us that when we differentiate that summation with respect to n, the 8th will stay at the front. For the 803n, the n goes, yeah. For the n squared, we times it by the 2, and then we're going to drop that power. And we want this thing equal to 0. As we do that then, that ends up being, the 8th isn't going to change anything, no, doesn't do anything. So it's just this bracket. So it's 803 on 6, which equals to, n is going to be 803 on 6. So that should hopefully be very similar to what we had up here. Yeah, you can see very, very, very similar. If we were to write this in terms of decimals, we have that it's 133 and 5/6. So maybe not decimals, but you know what I mean. Very close. Like, you don't get exactly the same number, no, because what we're really saying then is that like the peak happened just before this. Where this is the thing, this is the first value that went negative, then we can see like we should actually get the peak here. Again, I'd be plugging in the values of, like, if you're ever unsure, just put in all of them. Do you know what I mean? Put in 133, 134, see which one's bigger. So from there, lovely. Let's get this value then. So that's going to tell us this is fact number 9, fact number 10 even. So we have, again, the definition 2. We're going to have the, what the question was asking for, just max n, and the thing we just found then, so number 10. That tells us that the max value of the sum is the same as the sum of number 134, which is then we've done above. Do you know what I mean? So like this section of it at the end is the same. Nothing really changes from there. So this should be 2 and that. Yeah, we end up with the same things before. This equals the 2, 6, 8, 6, 7 on 4. Lovely jubbly. We can circle that one as well. Both ways you do it. Either one is completely fine. So this is your alternative way of doing it. Beautiful. Number 4 then. Yeah, number 4 is quite straightforward, wasn't it? So fact A, we were told that the first term of a sequence is k. We were given a way to find the next term using the current term. And then fact C, we were told some relationship to use later on. The first bit then, find the third term of this thing. We're going to take the first 2 facts, so fact A and fact B. Combine them together can give us U2, which should be taking this, but UN is now k. So it's going to be 3 lots of k squared, take away 1. We can call that fact number 1. And then fact number 1 and that definition of the next fact, or the next sequence, or next term, will tell us that U3 should be 3 lots of that entire thing, 3k squared minus 1, all squared, take away 1. Let's expand these brackets a little bit. What we're going to get, we'll leave the 3 at the front for a sec. 3k squared, squaring that gives us 9k to the 4. This will have 3k squared times 1, but then times by 2, because it's 2 of them. Think of the FOIL, it's the oi in the middle is the same. So we're going to have 6k squared, negative because of that negative. And then we'll add a 1 for 1 squared. That looks good to me. Let's just times everything there by 3 just in case. So 27 k to the 4 minus 18 k squared plus a 3. That looks good to me. Move that down a little bit. Was that actually correct? Let's make sure that is correct. 27 k4 minus 18 k squared plus should be 3. Definitely should be 3, shouldn't it? No reason that should be 2. I've got 2 different versions of this mark scheme, so let's check the other one as well. They're also saying 2. Everyone's saying 2. Oh, we need to take away the 1. Yeah, need to take away the 1. So that should have minus 1 on the end, and therefore, yeah, you get plus 3 minus the 1 plus 2. Lovely, that looks good. What do we need for finding k then? Well, let's label our old fact that we just found fact number 2. We're going to take that fact, the expression for the third term, along with this fact, and I suppose the expression for the second term, fact number 1, and use them all to find k. So we need c, we're going to need u2, which is 1, and we're going to need u3, which is number 2. All of those things mean then we can fill this in. So the u3 is just this thing we found here. So copy that over. If we duplicate that thing, get rid of the blue. That was u3. So if we take away 5 lots of u2, which was 3k squared minus 1, that should equal 11. This stuff all the same. Nothing's happened to that yet. This bracket, let's expand it out. I've got minus 15k squared plus a 5 equals 11. Collect some like terms. So I've got 27k to the 4. It's going to be minus 33k squared. And I've got 7 take 11 is minus 4. Does that match up? 27 minus 33 minus 4 looks good to me. From here then it's a quadratic. Yeah, I know it's 4 and 2, but it's still a quadratic in k squared. So we can factorize that then. How you want to factorize it up to you, do you know what I mean? Whichever way you want to do it. But we end up in this situation where k squared is going to be 4/3, or it's going to be minus, is that a ninth? Yeah, minus 1/9. From here then, we can square root both sides, but thinking about the fact that we have k squared, so this needs to be positive. So it tells us actually that k squared can only be 4 and 3. So final answer then, therefore, k is going to be equal to plus or minus 2 on root 3, which if we times top and bottom by the root 3, will be plus or minus 2 root 3 on 3. Does that match up? Does indeed. Lovely jubbly, that all looks good to me. Number 5. Yeah, I think, was it about a boat? You're in a harbour or something? I'm getting this bit. So some of these I'm not sure. It means I've just put question marks, but you're given some model of the depth of something. I'm assuming a harbour because it happens twice a day. Hence, I'm assuming this as well, just to be days. You're given some points, point 1, point 2. We have that when time is 3, the high side is 10. Well, the tide is 10. And when the time is 5, the tide is 17 on 2, so 8.5. And we have this observation we're given that when it's 10.5, we have a value of 4.9 is the actual observed value. Part A then of the question. Well, let's actually label these facts. That's going to be A. With this, we've got A, and I'll call it like A sub D. Do you know what I mean, for this fact? Where it's the fact, or like fact A about D, and this is the fact A about the time. This then, we've got the facts B1 and B2. And fact number 3 for the observation, fact C. That's good. So finding the actual model then, do you mean finding the model itself? We have this, we have our points. So let's take the expression that we were given, AD, and point 1. What's that going to tell us? Well, if we plug it in, we're going to have that 10 is equal to A plus B sine of 90. Sine of 90 is 1. So this is going to tell us A plus B equals 1. Let's take now again the definition of our model and that second point that we had. Combine them together. What do we get? 17 on 2 is going to equal to A plus B, lots of sine of 150. And now then, move this out of the way a little bit. What is sine of 150? Let's have a little look. Am I in degrees? I am. Sine 150, same as sine 30, isn't it? Yeah, it's a half. So this should be 17 on 2 is equal to a plus b on 2, 1/2 of b. Let's double everything. What do we get? 17 is 2a plus b. Beautiful, that looks good to me. Let's label these facts. That can be fact number 1. This can be fact number 2. Those together then, we can calculate a and b. Let's do fact number 2. Fact number 2. Take away fact number 1. What are we going to get? Well, this thing take this thing. Doing the right hand sides, 2a plus b, take away a plus b is an a. And then we have 17 take away 1. Something's not quite right there. What's gone wrong? Sorry, this is a 10, isn't it? This is a 10. So that should be 17 take away 10. So a is going to be 7. And now then, we can take that fact number 3, combine it with any of the equations we have. Let's have a look at with equation number 1, yeah. A plus b is 10. A is 7. B must be 3. Looks good to me. Yeah, looks good to me. I think that's all good. We actually wanted the expression though for the model, so let's always make sure we write that down at the end. So it should be 7 plus 3 sine of 30t. All looks good. Part B then, just plug in the value. We get given it's 10.5 in it, 21 on 2. Plug that in. What do we get? We first of all do need that fact, the definition above, don't we? So let's call that fact number 4. That wasn't a very good 4, was it? Try again. Number 4. Number 4. What is that going to tell us? Well, we're just going to take that value, plug it in. So 7 plus 3, lots of sine. What's that? 10.5. 10.5 times by 30 is 315. Yep, 315. So when we plug all of that together, what do we get? Let's have a look. 7 plus 3 lots of sine 315 is this lovely number. 14 minus 3 root 2. 3 root 2 all over 2, which is approximately 4.88. Looks good to me. Now we want to evaluate our model with the observation we had. So we observed that at the time we just checked, so 10:30 or 10:30, the actual observation was 49 on 10, so 4.9. The one we observed, or the one we actually calculated from the model, was 4.88. So using those kind of facts together, we can think about, fact number 5 and that observation, which was C. So if we think about 5 and C, the way I like to do it is with the percentage error. So percentage error is going to be the difference in those things. So it's going to be 4.88, take away 4.9. We do want the modulus of that difference, so just ignoring the negatives of it. Over the actual value, the one that we observed, 4.88, and timesing that by 100 to turn it into percent. What do we get? Well, top is obviously 0.02, isn't it? And dividing that by 4.88, times it all by 100, I get that we are off by a very small amount. Oh, keep that there. Yeah, very small amount that we're off by of 0.41%. That's very small. This is, very small. Very small. So what do we have from there? Therefore, I'd say it's pretty good. Do you mean? Yeah, it's reliable. It's a reliable model. Reliable. So that looks good to me. Let's keep going. Number 6. Yeah, simple. First principles. So let's write down what is first principles. We have basically the definition of this. So thinking about this, it's going to be the limit as h tends to 0 of f of x plus h take away f of x all over h. We've got the fact a at the top. Call that definition number 1. So a and 1 together, what do they give us? Well, we're going to be able to find f dash of x is going to be the limit as h tends to 0 of f of x plus h. So the x, let's put an x plus h in there. It gets cubed, and then we times it by 5. We take away 5x cubed. That's all over h. That cubed over there. Let's take the 5 out. The 5 is nothing to do with, like, it's not to do with h, is it? So 5 can be factorized out. Don't need to deal with that. And then the limit as h tends to 0. Expanding this bracket out, what do we get? X cubed. And then we're going to have 3x squared h plus 3x h squared plus h cubed. Take away still the x cubed on the end. And this whole thing is still over h. We have positive x cubed, negative x cubed, so they go away. 5 still there. Now we have the limit as h goes to 0. What we have, every term now left over has h's in there. So I'm going to divide this off. So we get 3x squared, it's not a 2, plus 3x h plus h squared. So now then, as we plug in that value of h, which we can do now, because at no point do we have, like, we don't break the calculator, no math errors going on. As we do, what do we get? It's going to be 5 lots of 3x squared plus 3x times 0 plus 0 squared. That inside bracket, that's 0, that's 0. So what are we left over with? Just 3x squared times 5. 15x squared. All looks good to me. Next one then, what do we have? Yeah, so I wasn't sure if you were given some, like, did you have to work these out, or were you just given these facts? Either way, we want to get the angle, BAC. What we're going to do then? Well, this is going to be fact number A. This is going to be fact B. I'm going to do them slightly differently. This is going to be fact B, and this is going to be fact C. So the one that it goes to, just to get my labeling a little bit easier to talk about. How we can do that then is, well, 2 different ways. We can either do the cosine rule. So doing that, what's going to happen? We need to firstly work out the magnitude of A, of A to B. So b4 squared, 16, plus 3 squared, which is 9, plus 1 squared, which is 1. All of that square rooted, so it's root 26. And similarly, we'd want to find from, sorry, let's back to B, and fact C is going to tell us that going from A to C, we can find the modulus of that. We have 9 plus 25 plus 4 for 3 squared, 5 squared, 2 squared. Square all of that. What do we get? That's 34, 38. So root 38. None of these are very nice, 19 and 2 and 13 and 2. But that's good. If we kind of draw the triangle out, what we can see, something along these lines, where we have A, we have B, we have C. We've just found A to C. We know that this has a length of root 38. We've just also got 26 square rooted. And thinking about this, we want to find the other length. So we need to know what B to C is, how long that is. And then we're looking for this angle in the end. So let's find B to C. So again, B, like fact B and fact C, they're going to tell us how to go from B to C. So if we're at B, we need to go negative through that, positive through that one. So B to C, which is going to be equal, yeah. So it's going to be, we want to do B to A, so that's negative A to B, plus A to C. So 3 take 4 minus 1. We have 5 take negative 3 is 8. And 2 take negative 1, 3. So if we take that fact, call that fact number 1. Number 1 is going to tell us that the magnitude of B to C is equal to 1 squared, which is 1, plus 64 for 8 squared, plus a 9, all square root of that. So it should be root 74. Looks good to me. I might just number my facts. That's actually called that one fact 1. This can be fact 2. This can be fact 3 then, and this will be fact number 4. This actually came from fact 3. Just so they're in order of how we're given them. Lovely. So we know that one then at the top right is actually root 74. Has that got a nicer version of itself? Nope, no it does not. So then cosine rule. We're going to take all of these facts. We have fact 1, fact 2, and fact 4. They give us the cosine rule. So a squared, 74, equals b squared, 26, plus the 38, minus 2 times b, which is going to be root 26, times c of root 38, and that is equal to cos of the angle. Let's call it theta. So cos of theta, and we're going to rearrange this for cos theta. So, well, for theta, I suppose. So theta inverse cos, we'll have the 74, take the 26, take the 38, all over 2 root 26, root 38. Let's simplify this down a little bit. Top row, what do we get? Well, if we add those together, that's going to be 58 and then 64, so minus, 10 on the top. On the bottom row, we can get rid of that 2 actually. Let's make it just a 5 on the top. And if we combine those together, what do we get? Root 26 times by root 38 is 2 root 247. I feel like something's gone wrong with the negatives. Yeah, we added this over and I took that away, so it should have actually been like the negative of all this. Whacking that in the calculator then, we should get the answer of 99, I think it was. Am I being silly? Was it 90.9? Hold on, where is it? No, 99.2. Yeah, 99.2. Lovely, jubbly. That all looks good to me. Yep, all looks good. Let's keep going then. So now some exponential model. Not sure again what this was modeling, but we have the values. So fact number A is going to be the actual definition of the model. B was the fact that when we started, we had a value of 25. And we have, again, we want to find basically at some point in the future, when are we at 35? And we also have, I'm assuming that t had to be positive. We didn't see it anywhere, but I assume that is true. So how would we find the actual model itself? Well, there's only one unknown in there. That's that k. And we have some point. We have 0, 25 as a point. So let's take A and B together. What do they tell us? Well, we can therefore write this expression, 200 plus 5 lots, or 5 plus k, e to the 0 is just 1. So it's going to be just 5 plus k. That should equal 25. So we can take that. Let's swap that 5 plus k and 25 over. 5 plus k is 200 over 25, which is 8. So k will be 3. That's good. Let's just move this down a little bit and rewrite our model. Forgot my dot. Yeah, and then let's rewrite the model. Didn't move that down enough. So we can then take this new fact of, let's call it fact number 1. Fact number 1 and the definition of the model, which was fact A. They tell us that the model can actually be written as 200 over 5 plus 3 e to the minus 3t on 20. Lovely jubbly. Let's look at the next ones then. So now we want to find the value of t. So that's the time that we hit 35 at. So let's look at an easier way of doing b than I just did. Let's go down. What do we know for this one then? Well, we want to find point t. That comes from fact number c. And we know that we can plug in the value of 35. So if we use c and our definition that we just found for the model, so fact number 2, that can tell us that 35 is equal to 200 over 5 plus 3 e to the minus 3t on 20. We're going to solve this for t. So what we're going to do, firstly, we're going to set this down here for a second to move out of the way. Let us swap these parts over. So 5 plus 3 e to the minus 3t on 20 is equal to 200 on 35. That we can cancel down a little bit, can't we? 200 divided by 35, what do we get? 40 on 7. I want to now take away that 5. So 3e to the minus 3 on 20. Yeah, if we take away 5 from this, what do we get? We get 5 on 7. So if I divide by 3, yeah, we're going to get 21 on the bottom there. Ooh. So 21 down there. And from here then, let's take logs of both sides. So minus 3t on 20 is equal to the natural log, 5 on 21. And let's deal with our negative 3 on 20 there. So t should be negative 20 on 3, log of 5 on 21, which is the same if we use the negative thing, negative reciprocal, do you know what I mean? Then what we're going to have is that this will flip over. No, this will stay the same, but be non-negative, 20 on 3. And inside will reciprocate, 21 on 5. Lovely. That gives an approximate value, if we double check that, 20 on 3, natural log of 21 on 5. Is that good? That is good. 9.57. Lovely jubbly. Let's do that. Let's keep going. What's that, number 9? Oh, we've got one more to do, actually. So the limit, as this thing goes to infinity, as t goes to infinity, we need to take our definition that we had, which was number 2. And basically, we're going to use that and we're going to build it up. So we don't actually need that quite yet. But what we're going to just state is the fact that if we have e to anything, so we can have e to 3t on 20, but the negative of that, that thing's always positive for all real values of t. And we're told that we only have real values of t. I'm assuming it's A-level maths in it, so you don't know, they're not going to do anything like that. From here, then, what can we tell? Well, we know if we just try and build this function up, we can work out what's going to happen to m. So times by 3. So 3e to the minus 3t on 20. That will also be bigger than 0. We can add 5. So 5 plus 3e to the minus 3 on 20 will be bigger than 5. So the bottom of our thing is always bigger than 5, and we're dividing by that thing. So effectively, that's the maximum value you're going to get for the actual range of this thing itself. So as t goes to infinity, this goes to 0 effectively, doesn't it? So it's going to tend towards this number. So what do we have? The the actual model itself. So this is now where we need to add in 2. So let's think about this one. Call that 2. This can be fact number 3. Yeah, fact number 3. So 2 and 3. This is going to tell us that our expression for the model, we need the denominator is bigger than 5. So the entire thing is going to be smaller than when we have 200 on the top, just the normal number on the top, and then the 5 on the bottom. This, if we divide it down, will be 40. Does that all look good? That all looks good to me. Is that the correct one? Let's find out. Yeah, 40. So we know it's stuck there. We just have to show at some point it's underneath. But what we do have is that at some point it was 35. So we should end up in a situation where, because we have this fact, number 4, and the model itself, well, it's the model itself, that is 2. What we have is that we're always less than this, and we know that we're in an increasing function as well. That maybe we should go and show that actually. So let's just take the model, which is 2, sorry, and we will differentiate it. So let's have a look at this. D itself was equal to, where is it? Up here. So differentiating that, what we're going to get, we need to differentiate. So dn dt will be, let's just make this a little bit easier for ourselves, 200 lots of 5 plus 3e to the minus 320t to the minus 1. So the 200 will still be there. The bracket, what we're going to get is that bracket will be there again, but we'll drop the power, 3e to the minus 3 on 20. Drop the power to minus 2, times by the negative power, and then also times by inside when we differentiate it. So the 5 goes away. The e stuff, we're going to have that negative 3 on 20 come down. So it can be negative 9 on 20. Lots of e to the minus 3t on 20. Minus there, they will cancel. And what we have then, this thing is a square, the first bit of it. So that's bigger than 0. This bit is e stuff, so that's bigger than 0. This is 200, so that's bigger than 0. So all of those facts together tell us that the derivative is always positive. So it's always an increasing function. It's always getting bigger, and it has an upper bound. So we have it's increasing. It's got an upper bound. So that tells us that the limit of that thing will be that upper bound. So the limit of, well, as t goes to infinity, of our model is going to be 40. I don't think you need to be as precise with this. You can probably, like, it's probably less than that. Do you know what I mean? Like, you can probably just do the stuff at the top, and that's probably okay. But this should do all of it, I think. Like, yeah, so you got an upper bound, but you're always increasing, so you will eventually get there. It's like a sandwich theorem. If I just keep pushing something to the side, it will get to the side, yeah. If there's an edge, eventually if I keep pushing it, it will hit that edge. Lovely, all looks good. So on this one, we were given, I'm going to guess some graph where you got like some values of it, you've got the y-intercept and you've got the gradient. Whether you work those out or just given them, not too sure. And then some model here, and we want to go through and find what that model is. From then you get, it wasn't natural log, was it? It was just standard log, I think, wasn't it, like log base 10. So log base 10 of A and log base 10 of B are going to be this. They come from the graph. So straight away you can work out what those are. So if we just label all our facts A, and again I'll do the fact about A can be fact A, the fact about B can be fact B. This therefore is fact number C. Move it down out of the way. Fact A is going to tell us something. Well, if we want to find what A is, it's going to be 10 to the power of 0.0304. Whack that in the calculator. What do we get? 10 to the power of 0.0304 is 1.07. Yeah, 1.07. And B. There's no, I've realized I've copied one bit down wrong. This does not have a 0 in there. It's just 0.304, not 0.0304. So that changes it slightly. We don't get 1.07. Let's take that 0 out. What do we get? 2. Not exactly 2, but 2.014. That's good. Same thing for B then. B itself will be 10 to the power of 0.0108. Let's plug that value in. What do we get? 0.108. I get 1.025. That's good to me. So label those facts. Fact number 1, fact number 2. So let's take fact 1, fact 2, and fact C. They tell us that we can write our model as A, which is 2.014, times by B, 1.025, to the power of T. That looks good to me. That was part A, wasn't it? So let's actually move that down a little bit, put part A up there. Yep, that looks good. Part B then, what we're doing? Well, we just want to plug in, find the value when it's year 1700, wasn't it? This, I think, was measuring from 1700, so that's just plugging in the value of 0. So doing that, let's take our expression, let's call that fact number 3. Fact number 3 then, that's going to tell us that L is 0. Plug in the value of 0, end of the 0 is 1, so we get that just number out the front, just A in it, 2.014. And this was in millions, was it? Yeah, it's in millions of tons. So millions of tons. Looks good. Next one, what do we have? Move that up a little bit. Let's actually circle our previous answer. And this one then, we want to find out the year 2000. So same idea. It's going to be actually 300 going into there. So if we again use fact number 3, L of 300, plugging that in. What number was it? 3281 million tons again. Millions of tons. I don't need of in there, do I? Oh, yeah, that'll do. No of. Million tons. Spot on. What's the reliability of our answer to not part B, part C? Yeah, it's basically this one. Like, is this reliable? I think this is why I was thinking about the 1900, because the answers all seem to say like, no, you've extrapolated. So we have extrapolated, and that tells us no. So reliability of C would be no. Let's write that down. So therefore, the reliability of C, just duplicate that, make it red. Make it red. And we have that is going to equal false. Or no. Reliability of C is no. Nice. Let's keep going. Number 10. Okay, partial fractions. Not too bad of a thing to do. Put that right down there. So A, I wasn't sure if you were given them or not, but either way, what A is going to tell us, because of the structure of it, so f of x will have to be equal to some constant plus some other constant over 1 minus x plus some other constant over 1 minus 2x. Lovely. And that, again, still equals the thing up here. So if we were to take that side and make it into one denominator, what we're going to have is a plus 1 minus x times by 1 minus 2x plus b, lots of 1 minus 2x, c, lots of 1 minus x, and that thing will equal the numerator we started with. So 4x squared minus x minus 1. So that's good. We can get a few facts from this then. Let's first compare the coefficients of x squared. In here, if we were to expand out these brackets, I get a minus x there and a minus 2x. So that's positive 2x squared. So overall, I'd have positive 2a x squared. So 2a, what's that? Not a very good 2. Right hand side, I have 4. So that's going to tell me a is equal to 2. Looks good. Let's keep going. What can we say then if we plug in a value of 1? So make x equal to 1. What do we get? This whole thing goes away, yeah? We get 1 minus 2. So that's going to be minus 1, so it's minus b. And over here then, I do 1 squared minus 1 minus 1. So 4 lots of 1 squared minus 1 minus 1. No, why does that not work? What's gone wrong here? Ah, okay. Sorry, plus 1 over there. That looks good. And from here then, what goes on? Yeah, so we're going to have 4 minus 1 plus 1 is 4. So b is minus 4. And that's not really implied. Ooh, not like that. We need to have kind of multiple of them. So last one, when we plug in 1/2, what we're going to get? The a's all go, b's all go. 1 minus 1/2 is 1/2. Times that by c, I have c on 2. Right hand side, half squared is a quarter. Times by 4 is 1. Plus another 1 is 2. Take away 1/2 is 1.5. So I have 3 on 2. So therefore, C is going to be 3. Looks good to me. Yep, that all looks good. We do want to find out the actual partial fractions. So let's call them fact 3, fact 2, fact 3, and fact 4. And then we want all those facts together. 1, 2, 3, and 4. And we can rewrite our f of x. So it's a, which is 2. Take away b, which is minus, well, plus b, but it was minus 4, over 1 minus x. And then we're also going to take away, or add on actually, 3 over 1 minus 2x. This, again, is not true if x is a half and 1, but I don't think you need to always write that down here. It's already been stated up there, do you mean? Don't need to state it again. That looks good. Oh, looks spot on. Full marks that one. Pull these up a little bit. We want to find the approximation of f of x. Okay, and find the approximation Order of x cubed, so our highest power is going to be x squared. What that means is that there's x cubed bits that we're just missing out. Do you mean we just not care about the x cubed bits and anything else higher powered? So doing this, we want to look at each one individually. We have 1 minus x to the power of minus 1. So what's that going to give us? It is the binomial expansion, yeah. So we have a 1 already, which is good. So it's going to be 1 plus n times by x, and then plus n minus 1, all the x stuff squared, and then 1 over 2 factorial, which is just 2, yeah. Looks good to me. Let's simplify this a little bit. What we're going to get, 1 at the front, plus x. Here, what do we get? 2 and 2 will cancel off. The negatives go with the negatives. The 2 goes with that 2. So effectively that doesn't matter, that doesn't matter. Plus x squared. For the other bracket, what do we have? 1 minus 2x, all to the power minus 1. So again, 1 at the front, plus n, lots of x, plus n minus 1, x's all squared, 1 over 2 factorial. Calculate this again then, 1 over there, plus 2x. And here again, negatives will cancel in the same way. So I've got that one and that one go out. This 2 can go with this 2. So this fraction's gone, this is gone, this is gone. We're going to have 4x squared. So we can therefore use these two facts that we have. What facts are they? Number 5 and the number 6. Alongside what we had up above. This one, so actually let's relabel them. That's going to be, that can be 5. That can be 6. This one can be number 7. So taking all of those together, we have 5 and 6 and 7. We're going to have the f of x is approximately these bits added together. So 2 minus 4 times the thing we found on the top row. 1 plus x squared. And then we're going to add on 3 times the second row. 1 plus the 2x plus the 4x squared. Let's keep going. Just expand these brackets, collect the like terms. How many bits are we going to have? X squared minus 4 plus 12 gives me an 8. X's, I've got 6, I've got minus 4, so I've got 2. Numbers, 2, take 4 is minus 2, plus 3 is a plus 1. That looks good. Is that what they get? Yes, it is. So this thing, we would have like, yeah, plus some x cubes at the end, but not so interested in that here. Find the range that this approximation is valid for. Well, we had these two binomial approximations. So where we have 1 minus x to the minus 1, that tells us that we need to have our modulus of x less than 1. So call that fact number 8. If we were to have the other bracket, 1 minus 2x, that tells us that the modulus of x is less than 1/2. And then fact number 8 and fact number 9, they tell us the new fact that we must be less than 1/2, i.e. making sure that we're fitting both. So we wanted really to have the intersection of these two facts, but you can think, and it's kind of the same thing what I'm saying. Lovely. Looks good to me. Was that correct? Yep. Yes, it was. That was number 10. Let's keep going. This one, no faff, just an integration, yeah. You got 8 marks for it. You could just go through and do the whole thing in one go. We will, though, kind of walk through the steps as we go. So let's do a u sub. We're going to let u equal that horrible bracket, 5 minus 2 all square rooted. So we can go from that fact. That's actually going to be fact number 1. Fact number 1, we can rearrange for x. So squaring it, adding 2, divided by 5. Squaring it, adding 2, divided by 5. And we're also, let's call that fact number 2. Fact number 2 then can find as dx du, which should be, well, this is going to be just 2/5, that goes away. This will be u squared on 5, so it should be 2/5 of u. which is then going to be that dx is 2/5 of u du. That fact will be useful, so we'll give it a number. We also want the limits, don't we? So we're kind of going to use the actual definition of the thing, the limits up there. So taking a and taking the value of fact 1. This will tell us that when we want to sub in the values of 27 on 5 and the values of 3 on 5, what do we get? Well, to get x, we square them. So 27 on 5 squared, we add 2 and divide by 5. Nope, tell a lie. That's how we go the other way around. We're going to take the 27 on 5 times by 5 is 27. Take the 5 is 25. Square root it gives you a 5. Here, times by 5 is 3. Take 2 is 1. Square root that. 1. That looks good. They're going to be kind of fact 4 and fact 5 together. And now then, we can stick all these bits together. So we need to take the definition of the actual integral itself, a. We need to take the value for u, which is 1. We don't need the value for x. Don't need that one. But we do need the expression for dx. And we need both of our limits, 4 and 5. All these facts together then, they're going to tell us that our new integral will be, so the 3/5 became a 1. The 27 and 5 became a 5. On the bottom of the fraction, 3 plus u. The dx has been replaced by 2/5 of u du. So we can take that 2/5 out the front. Integral 1 to 5 of u du 3 plus u. Looks good to me. Does it look good to the mark scheme? 2/5 out the front. U over 3 plus u. 1 and 5. Yeah, happy days. Looks good to me. Now let's just keep going. Just want to carry on with this, yeah. So let's give this a number. This can be fact number 6. And fact number 6 then, what do we need to do? Well, we're going to do another u sub. I think we're going to do, weirdly, another u sub just to like move the 3 over, unless I'm being really stupid about it. But I think that that's what we want to do. So we're actually going to, whether this is the easiest way, am I being really thick here? I think okay, no, yeah, we can do it a different way. So yeah, 6. We're going to do this kind of sneaky thing where what that's going to tell us, still the 2/5 at the front, 1 and 5, yeah, that's all good. This u, I'm going to rewrite as like u plus 3 minus 3, and then we can steal like one part of it. So u plus 3 minus 3, so that plus 3 minus 3 is just 0, yeah. 3 plus u du, and then yeah, we're able to effectively take like the u plus 3 and the u plus 3 there, and then take away 3 over the 3 plus u. So that first term is just 1, yeah? 2/5 of the integral of 1 minus, here, how I'm going to write it is 3 times 1 over u plus 3. Reason being then, this one is now in the log integral form. So we can perform our integration. 2/5 at the front still. First bit 1 becomes u. And this thing will be minus 3 natural log u plus 3. We're going to plug in 5 and 1. 2/5 at the front still. Plugging in 5, we'll get a 5. Take away 3 log 8. And then we'll take away a 1 and then add on a 3 log 4. Let's deal with our logs. We've still got 2/5. The numbers, the 5 and the 1 make a 4. This is going to be, well, this is 2 cubed. To bring that down is 9 minus 9 log 2. Let's put log 2 at the front. So log 2, lots of 9 there. This is squared, so it's 3 times 2 is 6. And plus a 6 there. This was a minus 9, actually minus 9. So what do we get in that case? This is minus 3, yeah. So with that minus, makes it positive 3. So 2/5 of 4 plus 3 log 2. And is that how they wanted it? Well, should it be minus? Somewhere it should be a minus, shouldn't it, somehow? This is negative, this is positive. Yeah, I've done it. It shouldn't be minus out the front, it should be positive there. So that becomes a negative, therefore, just to double check that. This makes -3, this is positive, -3. So 2/5, but if we expand this out, then we had 8/5 minus 6/5 of log 2. Looks good to me. Let's keep going. Number 12, not too long to go. We had some parametric thing. So some curve. I'm not sure where the actual domain of the curve was, but I'm going to guess here it's 2 pi. 1 point, which is at t, is pi on 4. And then just another curve. Yeah, again, how did this come? I don't know. Let's look at doing part A by putting these down here. So what needs to happen? Well, we want to find point P. So we need our expression of C. So okay, this is A point C, yeah, like this is fact A, but point C of it. So A sub C. This can be A sub C, A sub X, sorry. This can be A sub Y, and this can be A sub T. This then can be B. So what do we need to know? Finding point P, well, we literally just want to take all of these definitions and plug in the values. So taking AX, AY, and B, taking all of those together, what we're going to get? That P is equal to 1 minus cos of 2 times pi on 4, pi on 2, and then it's going to be sine pi on 4 times by sine of pi on 2, which when we evaluate all of those bits, what do we get? Let's have a look. Change into radians. So 1 minus cos of pi on 2 is 1. Should have probably known that one. And then sine of pi on 4 times by sine of pi on 2. Oh, that's not that. Pi on 2. I get root 2 on 2. Does that look good? Yep, looks good to me. Wonderful. Question B then, it's down here. So now we want the normal to our curve at that point P. So to do that, we need to find dy dx. So let's take in our facts of A, AX, and AY. And they're going to tell us that dy dx will be the same as differentiating the y part. So we're going to use the product rule for that. Let's differentiate sine. What do we get? We get cos. So cos of t times by the bit that we left over there, which is going to be just the sine of 2t. And then we'll add on, leave the sine alone. Differentiate the sine 2t. What do we get? We get 2 at the front. Times by cos of 2t. That's the dy dt. Doing this all over the dx dt, which is going to be 1 minus sine, minus cos, sorry, becomes positive sine. The 2 will come out the front, so 2 sine 2t. We could maybe simplify this. There probably is ways that we can go through and simplify this thing. Is it worthwhile? Not really, for what we want to do with it, because we just literally want to find the gradient, like use it to find something. So if we actually just plug in, like let's call this something, that's just going to be fact number 1. So if we take fact number 1 and where P is, which is B, we can figure out if we evaluate dy dx at P. So just plug in the value of pi on 4 everywhere. Cos pi on 4, sine of 2 times that, so pi on 2, plus 2 sine of pi on 4, cos of double that, so pi on 2. Again, all over, it's not very good. All over 1 plus 2 sine of the doubled, so pi on 2. That looks good. We plug that all in the calculator and we get some number out. What number do we get out? We get root 2 on 4. I may have written this down wrong. I'm hoping that it's like all correct in what we're doing. Do you know what I mean? I think I didn't like plug that in the calculator to double check, but I think it should be fine. So that's the gradient at that point. So if we take number 2, that should tell us that the gradient of the normal is going to be -4 on root 2. So times the bottom by root 2, we'll have 4 root 2 on the top. We'll have a 2 on the bottom, so it's 2 root 2 altogether. So that's the normal gradient to that thing. We then want to find the equation of the line. So y minus y1, which is given to us as point P above, which is root 2 on 2. And that's going to equal m, so minus 2 root 2, lots of x minus 1. And then we start rearranging that. What facts did these come from though? So it came from the point P, which actually let's call that fact 0, I suppose, as we've gone back in time. So fact 0, and the value that we got for the gradient, which is going to be fact number 3. Those two together tell us this. And then we can rearrange this a little bit. What are we going to get out is, if we add that over, times by this thing. So we're going to have negative 2 root 2, lots of x. This would be positive 2 root 2, yeah. And then we're going to add another half, so it should be 5 halves of root 2. And let's keep going. We want to end up in a situation where we have, will it show that 5? We need a 5 equals. So it's going to be this 5, yeah. Let's make that 5 the subject. Let's just banish my little bit down here out of the way. Down there you go. Let's times 2, well, we're going to times through, or divide through basically by root 2 on 2. So it's going to be 2 on root 2, lots of y, is equal to 2 on root 2, the negative, and then times by 2 root 2, lots of x, plus 5. So this bit times on the bottom by root 2, well, we have 2 root 2 on 2, so that is just root 2y. We will have 4, and then these bits cancel out, so that's going to be 4x, and we'll add it over the other side, so 4x there, and that equals 5. Does that look good? Looks very good, doesn't it? Next one. So we want to take the curve we just found there and have it intersect with the second curve. Nothing to do with this normal, was it? I don't think. Or was it actually, no, sorry, intersection between the normal and the new curve we're given. Not C1, but the normal. We should probably really label this as normal somehow. Do you mean this is there? Didn't really steal that D. 1 sec. Move that over. Slightly different to how I've labeled it. Oh, I still see one there. I'll fix that in a second. I'll fix that later on. So yeah, we found the, well, want to find the intersection points and the x coordinates of those. So let's have a little look. Just the notation there. Yeah, this middle bit is the intersection. So that's a set of intersection points. Hence why I put this bit there. You don't kind of need that, but it's just so I can remember in the future that definitely is a set. And I want the x coordinates of those things. There, you could just write that, I think, with that. But with it being a set, I'd rather use curly braces for it. So this is good. We want to find them when they're equal to each other. So we have an expression here, and we have an expression for this one up there. So if we square this thing, I have to give it some name. So that's going to be number 4. So if we take number 4 and we can square it, what do we get? 2y squared is equal to, well, this would be 5 minus 4x, yeah. So it's going to be 25 plus 16x squared. 5 times the 4 is 20, times by 2 will be 40x. Just going to reorder those so it's in like, whatchamacallit order. The quadratic, like normal order, do you know what I mean? To be to deal with. Looks good. And we have that thing. We also then have our expression for C. So let's give that a fact. That is fact C. This is going to be fact 5. So 5 and C. Basically going to mean that we can replace those 2y squareds with each side. So 16x squared minus 40 plus a 25 equals to the expression in C, x squared and 2 minus x. Let's bring this all to one side. The x cubed is negative on that side, so I'm going to add that over. So it should be x cubed. The other one I get is 2x squared, so I'll take that away. So plus 14x squared minus 40 plus 25 will all equal 0. This then we just want to keep solving it. We want to go through and end up with all our solutions. If we factorize this, x minus 1 comes out, and we also can get x squared, that's a 2, not an x, x squared plus 15 minus 29. Is that 29? I think that's a 29. Nope, it's 25. Sorry, 25. G equal to 0. We want to find all the x coordinates, so evidently x equals 1 is the solution. That's good. Let's look at this one then. So if we kind of label this thing, let's label it triangle for discriminant. This is going to be fact number 6. Let's just write it from here actually. So x equals 1 is a solution. That can be fact number 6. And then the triangle, what's that going to imply? Well, if we think about this, we can find out basically, let's not call it triangle actually, let's call it Q, because we want to find we want to find the discriminant of Q. So Q itself is going to imply that the discriminant of Q is b squared, so 15 squared, so 225, minus 4 times a with 1 times c of minus 25. So this thing is 325. So we have two solutions, that's good. So lovely. We can therefore use this thing. Let's call this fact number 7. So Q and fact number 7, they tell us that we're going to have some roots. So let's find out what they're going to be. We do like the quadratic formula basically. So minus b, well, not basically exactly that, minus b plus or minus, I would do this thing, but it's going to be just root 325 on 2a. Root 325, what does that become? Root 325, 5 root 13. So it's minus 15 plus or minus 5 root 13 on 2. We wanted to look for all the x coordinates, but yes, one thing to think about. So you can get then, this is 8. We have therefore 6, 7, and 8. Well, 6 and 8 tell us that x is equal to either 1 or those things. But let's actually combine this together with up here and use AT. So we want some other fact very quickly. That's good. So if we use fact AT, which is the domain of T, and fact AX, what we can get, if you look at the definition of X, like cos T is between minus 1 and 1. So is negative, minus 1 and 1. So we're adding 1 or taking 1 from this. So we're between 0 and 2. Again, these might not include the equal part. It would depend exactly on what your domain was, if it's the 2. The main bit we want to think about though is that we don't care about the negative values that we get out. So all of our answers should be between 0 and 2. This then, fact number 9. So let's take fact number 9. The 2x values that we found so far of fact number 6 and fact number 8. And they're going to tell us then x can be 1. That's good. We obviously can't do the negative, can we? Negative and a negative will make something more negative. Let's double check the positive. Is it bigger than 2? So 15 plus 5 root 13 on 2 is a number that is 16. So that's it. We should just have 1 as an answer. I've been seeing negative and then, oh, sorry. No, that should have negative 15 on top. Yeah, so it's fine. It ends up being 1.5-ish. So if we have like the positive one, 5 root 13 minus 15 on 2, and that's roughly equal to let's do it down here. So that implies x is 1, or it's going to be, the other way around. This thing is just roughly equal to 1.5. Yeah, 1.5. Lovely. That looks good to me. Circle our answers. We've got those ones, and those ones. That looks good. Keep going. Number 13. It seemed to get easier, this paper, didn't it? As I was going through, everything seemed to get a bit easier. Dy dx then, nice and straightforward. We'll take our definition of C. So we'll call that fact C. I didn't know if it was equal to something. I don't think you didn't need it in the question. So there could have been something on this side, but if it was something, it's a number, it's some constant number. Yeah, we're going to take factor C and just differentiate it. It is implicit, yeah. X squared becomes 2x. 2y squared becomes 4y, but I used the wrong letter. I used y when I should have used x. xy, if we keep the y still, differentiate the x becomes 1 times by the y. Keep the x still, differentiate the y, becomes dy dx. So we have x dy dx minus x minus 1 plus 5y will become 5, but I used a y when I should have used an x, and that equals to 0. So we can rearrange that, call that fact number 1. Well, no, we can just go straight away. We don't need that fact for anything, do we? Rearranging this then, dy dx. What bits didn't have a dy dx? These, and these. So I'm going to have y plus 1 minus 2x. Which bits did have one of those? We have a 5 minus x minus 4y. But they'd have been added over and divided. So all the opposites. 4y plus x minus 5. Is that good? Let's have a look. Number 13. I get y plus 1 minus 2x. Yep. 5 minus... Oh, it's the negatives. Hold on a sec. These ones... Did I already do... Oh, sorry. I did it on the top, then I didn't need to do it on the bottom as well. I did it on both rows. 5 minus x minus 4y. Looks good. Some rules, obviously, about like what you can't have on the bottom. Do you mean we can't be valid at certain points, but not the end of the world here. Don't think you need to write that down for the question. For this, then, we want to find the gradient of the normal at P. We were told that's what P is. So to find, first of all, yeah, just find the normal, find the actual gradient of it. So dy dx, what factor do we need for that? We're going to need not only point P, so that's just factor P, yeah. And this one, which will be factor 1. So P and 1, what do they tell us? They tell us that dy dx evaluated at P should be all of these bits, but plugged in. So y is 10 minus, that can't be right, surely, 3 over 3 root 2. What number should that have been? Where is it? It does have that written here, 10 minus 3 on root 3. Do I have a different version? Hold on. 10. No, this was 12, sorry. No, 13. We have... it should be over 2. It should be over 2 on there. That was good. So yeah, 10 minus that thing. So 3 on 2, root 2. And then we need to add 1, take away 2 times the x value. So 2, and then take away 12 root 2. All divided by 5 minus x. So minus 1 minus 6 root 2. Take away 4y. So take away 40 plus. Times that by 40. We'll times it by 20, really. So it's like 60 root 2. I think that's all good. Like I said, I might have typed in some of these slightly wrong, but everything should be fine in terms of the method. Plug it in them. What do we get? We get 3 root 2 minus 2 all on 8. So if we want to find, therefore, the normal gradient, we need to take this fact, which is 2. So 2 is going to imply that the gradient of the normal will be negative 8 on 3 root 2 minus 2. But we want to leave that in, I think they specified the form in it, not in having the like rationalized denominator. So if we times by 3 root 2 plus 2, same on the bottom, 3 root 2 plus 2. Top row, what do we get? Minus 24. Lots of root 2, minus 16. All over, well, 3 root 2 squared. What do we get there? 3 root 2 all squared, 18. Take away 2 squared is 4, so that's 14 on the top. 2 squared and everything, don't they? So it's going to be 12 root 2. Half of this one will be 8. It was 14 on the bottom, so now it's 7, but we have the negative. Yep, looks good. Oh, looks good to me. Next one then, number 14. this thing. So yeah, it's just not too bad at the end, was it? Let's keep going. Move that down. Call this fact A. Yeah. What's fact A going to tell us? Let's actually do the question. So fact A tells us that when we differentiate, what do we get? Well, when you have like a weird, you've got a base that's not e, yeah, we still get the same thing out. It's going to be like just normal 6 to the power of minus 3x. You're times by the minus 3 because of like the power at the top. But where it's not e, it's 6. We need to times by the natural log of 6. So that should be good. Let's just expand some brackets. Minus 3 log 6 of 6 to the minus 3 of x. That looks good to me. Does it look good to the mark scheme? Minus 3 log 6 times by 6 there. Yep, looks good. Part B then. Set that thing. Let's call it fact number 1. Set that equal to minus 1. Find the value that you want from it. So if we take, just take fact 1. What we're going to get, minus 3 log 6 times by 6 minus 3, 6 to the power of minus 3x equals minus 1. Let's get rid of that negative and that one. Rearrange for the 6 to the power of. 6 to the power of minus 3x will equal to 1 on 3 log 6. So we can reciprocate that, get rid of the negative on the left. 6 to the 3x is equal to 3 log 6. We're going to then take this to the base, like log base 6. So it's going to be 3x is equal to log base 6 of 3 log log of 6. And then we want to do 1/3 of that. Log base 6 of 3 log of 6. Does that look good to me? I think that looks good. Let's get decimals just in case that's what you guys wrote down. So 1/3 log base 6 of 3 log 6. What do we get? This is roughly 0.313. Looks good to me. Let's keep going. Last one then. And again, not too bad this, was it really? So what do we have? We have some circle, call that factor C. Some line, call that factor L. Find the center of the circle. I think I was doing the exam and this was the last thing that came up. I'd be quite relieved. Do you know what I mean? That this is what was happening. So hopefully I get it right now. Do you know what I mean? So what do we do? X's. I got x squared plus 6x. Let's actually put the question in there, up there before we do anything. Fucking what am I doing? There we go. So yeah, taking factor C, it tells us that we're going to have x plus 3 squared minus 3 squared, which is 9, plus, same idea for y minus 2 squared, take away 4, and then take away 62. This is good. So that tells us we have x plus 3 squared plus y minus 2 squared. This is going to make 9, 13, 75. So that equals 75. And that's the same as then, like, it's going to be root 75 squared, isn't it? Is that anything nice? Root 75. 5 root 3. So this is 5 root 3 all squared. Call this fact 1. Fact 1 tells us that the center of C is going to be negative 3 and 2, looking inside those brackets. And then that's good. Let's go down and do 2 as well at the same time. The radius of C, let's just copy that and colour it in, a bit easier. The radius of C will be that square root thing we found. Get rid of u. Is 5 root 3. Lovely jubbly. That again came from fact number 1, didn't it? Beautiful. Let's check the mark scheme. Is that good? 5 root 3 and minus 3, 2. Wonderful. Lovely. Lovely. Last question then in the whole paper. We want to find the intersection points, and we want the set of those to have, like, we want to find the set of intersection points given that we have 2 intersections. Find the range of values for that thing. Let me rephrase that. Range of values for k such that the number of intersections is 2. So what do we have? Well, we can take our expression for the curve and for the line and sub them into each other. Should we take that one or should we do this one? I think this one's actually probably easier. So it's going to be x squared, y squared. Well, y is now 2x plus k. So we're going to have 4x squared plus 4kx plus a k, all squared. And then we're going to have plus 6x minus 4y, so minus 8x minus 4k minus 62, all equals 0. Collect some stuff up. How many x squared do I have? I've got 5 at the front. How many x's have I got? Let's just tick some things off. So that's done, that's done. X's, I've got 4k plus 6 minus 8, so that's minus 2. Lots of x. And then how many normal numbers? I've got a k squared minus 4k minus 62. Plus k squared minus 4k minus 62. This then, we want to make sure we have 2 roots, 2 real roots. So let's call this a fact, fact number 2. The fact that we have fact number 2 and 2 real roots, that implies that the discriminant of this thing, so b squared, take away 4 times a, so that's 20, lots of this stuff. That needs to be positive. Expand my brackets, 16k squared minus 16k plus a 4 minus 20k squared plus 80k plus some big number. 20 times 62, 1240. That's all bigger than 0. Let's collect some like terms. I've got minus 4k squared. I've got 80 minus 16, 64. And I've got 4 plus 1, 2, 4, 4. Well, plus 120, 1240. So that's going to be 1244 altogether. Bigger than 0. Let's do the opposite and like move this over then. Yeah. So I'm going to have k squared. I'll divide by 4 at the same time. K squared minus 16k. Take away whatever this number is divided by 4. 311. 311. And we want that now to be negative, less than 0. Because it was this side and we've taken it over to the side. This is looking not too bad. Let's think about factorizing this thing then. Well, completing the square looks quite nice actually. So we'll have k minus 8 all squared minus 64 minus 317. 311. 311 plus 64 is 375. Again, less than 0. So we can see now that we need to have adding the 375 over, square rooting, we'll have 375 square rooted. And it will be like 8 plus or minus that, yeah? They're going to be our value for like the critical ones. So if we want to be less than, this was just a normal positive quadratic, we want to be less than 0. We want to be between these 2 answers. So we need to have 8 minus root 375 is less than k is less than 8 plus root 375. Can we simplify that down? Root of the answer, 5 root 15. So 8 take away 5 root 15 is less than k is less than 8 plus 5 root 15. Is that good? Looks good to me, but we want it in index form, set notation, don't we? So it finds our set. K is some real number. Let's write that a little bit nicer. Some real number such that we have this condition from above to be true. So let's just copy that down. Duplicate that, whack it in there. Close our set. Circle our answer. Finish the paper. Lovely. Yeah, that's really good. As they go, much better than paper 1, wasn't it? So maybe this, like, what's the grade band in this one? 100% for an A star. Do you know what I mean? Like, looking at it, there's not a huge area of anything that's tricky as like compared to what it could be. Do you know what I mean? This maybe if you don't know this fact, then you're a bit screwed, aren't you? and this one maybe the integration. This is a little bit tricky, obviously, but again, none of it was really, I don't think, that bad on the grand scheme of things. Even this integration, like, it looks horrendous on the face of it, but it just disappears immediately, and you're just done. This one, again, like, a little bit sneaky note in that fact, but if not, you can always just do another U sub when you're fine. So overall, yeah, really good. Thank you to everyone that like collated these mark schemes, these like community mark schemes. I was able to then work through and like figure out what the facts were you were given anyway. Whether there's some context I've missed out, probably is the case, but not too important. So yeah, hope you enjoyed. Thank you ever so much for watching.